boys and girls. Today's learning goal is I will be able to use multiplication to connect volume as packing with volume as filling. Last week we talked about how volume is the amount of space that is taken up in a three-dimensional space. We looked at volume by putting cubes into a three-dimensional space, and the particular space we talked about are rectangular prisms. We put cubes inside rectangular prisms and calculated what the length was, what the width was, and height, and then all together we looked at how we can calculate the length, width, and height to find the volume. Today, we're going to be looking at volume as filling when we're referring to filling a three-dimensional shape with liquid. That is what our focus would be on today. So here's today's problem. A small fish tank is filled to the top with water. If the tank measures 15 centimeters by 10 centimeters by 10 centimeters, what is the volume of the water in the tank? So I'm just going to reread some important things that we need to pull out from the problem. Now it says a fish tank is filled to the top. That's important to take note of, because if the fish tank is filled all the way to the top, will it have the same height as the tank? Yes. If it's filled all the way to the top, the height of the tank and the height of the water will be the same. Then it continues to say if the tank measured 15 centimeters by 10 centimeters by 10 centimeters. So those are the dimensions of the tank, right? The length of the tank is 15 centimeters. The width of the tank is 10 centimeters. And the height of the tank is 10 centimeters. So those are the dimensions of the tank, the length, the width, and the height. Then it says, what is the volume of the water in the tank? It's not asking me for the volume of the tank. It's asking me for the volume of the water inside the tank. So I'm just going to draw some squiggly lines just to show that this is where the water is, right? The water is filled all the way to the tank. I'll draw it a little bit neater. That's the water in the tank, right? It's filled all the way to the top. So we want to figure out what is the volume of the water in the tank. Not the tank, but the water in the tank. Well, you might say, well, Mrs. Grant, if the water is filled all the way to the top, wouldn't the volume of the tank be the same as the volume of the water? And I would say to you, I absolutely agree. We talked about in science that, water takes on the shape of the object that it's being poured into. So in this particular case, the water is going to take on the shape of this fish tank. So the water, being that it's filled all the way to the top, is going to have the same length, it's going to have the same width, and it's going to have the same height. So with that being said, what would be my equation that I would have to write to figure out the volume of the water in the tank? If you said the equation would be volume equals 15 times 10 times 10, you're absolutely correct. I would plug in my length being 15, my width is 10, and my height is 10. Now I'm going to go ahead and solve and find the volume of the water in the tank. Okay, so we know 15 times 10. We have 1 power of 10 there, so we could drop our 0 down. 15 times 1 is 15, so that's 150. Then we're going to multiply it times the height, which is 10. All right, so then we could calculate. We have a power of 10 there, and then 150 times 1. Our volume would be 1,500 cubic centimeters. Now, the problem says to express our answer in milliliters, right? Milliliters is usually a unit of measurement that we use to measure liquid, okay? So that would actually equal the same answer, right? 1,500 milliliters is the amount of water in the tank, 1,500 milliliters. So 1,500 centimeters is exactly the same as 1,500 milliliters. All right, so our answer again is the volume of the water in the tank is 1,500 milliliters. So in this situation, the volume of the water in the tank and the volume of the actual fish tank were the same because the tank, again, was filled to the top with water. Now, in life, that's not necessarily what typically happens. Oftentimes, the amount of water inside of the tank is different from the volume of the actual tank. So here is our part B. So we're going to build off the first part of the problem and go on to the second part. It says, part B says, after a week, water evaporates out of the tank. So the water is 9 centimeters high. What is the volume of the water in the tank? Now, let's think about some important information here. It says after a week, water evaporates out of the tank. So that means that some of the water has dissolved. Some of the water has gone down, okay? So it's no longer filled all the way to the top. As you can see in the picture, let's look at this picture. Here's where the water stops, right? It's no longer filled all the way to the top. If you compared it to this problem, the water was filled all the way to the top. Here, the water is no longer filled all the way to the top because some of it has evaporated. The problem then continues to say, so the water is now 9 centimeters high, okay? So let's go ahead and mark that on our drawing, that the water is now 9 centimeters high. Now, as you can see, again, the water has gone down. It's now 9 centimeters high. It's no longer filled to the top. I want you to think about this question. Does this change the height of the tank? If you answered no, because the tank doesn't change size. Remember, the tank, when it was created, it was 10 centimeters high. That's the tank. When they built it, that's how tall it was, 10 centimeters. However, what has changed is the amount of water in the tank. Now, if we look at the tank, the height of the water in the tank is now 9 centimeters. So it's 1 centimeter less than what the actual height of the tank is. So the water in the tank is 9 centimeters, but the actual height of the tank has not changed. The tank's measurement is still 10 centimeters. The only thing that's different is the water inside the tank because some of it has evaporated. Now I want you to think about this question. Does this change the length of the tank? If you answered no, it does not change the length of the tank. You're absolutely correct. If you think about the length is 15 centimeters. The water is going to fill up the bottom of the tank. The water's length is not going to change. When the tank was built, the length of the tank was 15 centimeters. When the water is poured into the tank, it's going to fill up the bottom of the tank. So the length will remain 15 centimeters. Will the width of the tank change? If you said no, your answer is correct. The width of the tank will not change. When the tank was built, it had 10 centimeters as its width. Therefore, the only thing that has changed is the height. So our length is the same, 15 centimeters. Our width is the same, 10 centimeters. And our height is now 1 centimeter less, so it's now 9 centimeters. Now I want you to think about this. Will the volume of the water change? Remember, when the water was filled all the way to the top, the water in the tank was 1,500 milliliters. Will the water of the tank now change? If you answered yes, you're absolutely correct. The volume in the tank will be less because some of the water is gone. The water won't be as high. The water level has gone down 1 centimeter. So that's like taking out 1 centimeter of water. However, the layer of the bottom of the tank, the 15 by 10, will remain the same because we're pouring out a layer. So now we're going to go ahead and find the volume of the water in the tank now. What would be the equation that we would have to write to figure out the volume of the water in the tank? If you said volume is equal to 15 times 10 times 9, you're absolutely correct. Remember, the height, 9, is now the new height of the tank since some of the water has evaporated. So let's go ahead and find the volume of this tank. So 15 times 10, we have 1 power of 10 there. So 15 times 1 is 15. So that's 150, and then 150 times 9. I'll go ahead and do the calculations at the bottom. 150 times 9. 0 times 9, that's 0. Remember, we're going to multiply all the numbers by 9. Let's rewrite that so it's a little bit neater. Times 9. All right. Again, we're going to multiply all the numbers at the top by 9. So we know 0 times 9 is 0. 9 times 5 is 45. Regroup. And then 9 times 1 is 9. Then add 4. That's 13. So the volume of the water in the tank is 1,350 cubic centimeters. And I want to express my answer in milliliters because we're talking about water and we want to use units of measurement that represents water. So we know that 1,350 cubic centimeters would be the same as 1,350 milliliters. Now, as you can see, the volume of the water in the tank is actually less than what it would have been in part A. Remember when it was filled all the way to the top? It was 1,500 milliliters. But now that some of the water has evaporated, the water of the tank is now less. Okay, it's 1,350 milliliters. I hope you found this lesson helpful. Just before you leave, remember to complete the exit ticket that I have following this lesson. Have a good day.